books, the Maker Village, demos, vendor tables, and more. And this presentation is why you should be an amateur. And we're going to talk about a few things. We're going to talk about what amateur radio is and isn't, what you can do with amateur radio. Oh, I'm sorry, I was supposed to give a heads up to you guys in the back. Pardon me. How amateur radio can benefit you, how you can benefit amateur radio, and how to actually become an amateur. Before I forget, Sunday, 10 to 1, testing on the 6th floor. I'll hopefully remember to say that again. Who am I? I'm amateur radio operator N1WBV. I hold an extra class license. I've been into radio since the late 1980s. I saw my first shortwave radio back about then, and I fell in love. Licensed since 1995 as an amateur radio operator, and a mild-mannered InfoSec practitioner by day and a wild, crazy geek by night. So everyone sort of has stereotypes amateur radio. They think big radios, they think cars full of gadgetry that you actually can't drive, and they think old people with huge antennas. No. This is because this is exactly what we aren't when you're talking about hacking. You're no longer the guy in front of his computer smoking a cigarette, and I don't know what that website is, but that's whatever I pulled up on Google image search. So here's what amateur radio is, and some people might not realize this. On the left there with the computer and the Wi-Fi antenna, it's a 25-mile Wi-Fi link out to an island, and I believe it was in Norway. And you actually, down in that green and yellow thing down on the bottom right next to the laptop, is a battery, so that means that it's completely off the grid. Over here is Sunyata Williams. She's the International Space Station flight engineer for Expedition 14 and 15, and she's doing an amateur radio contact with a school. I think it's in Indiana. I'm not sure, but she is an amateur radio operator, and I'm drawing a blank on her call sign, and I apologize if she ever watches this. But she was fairly active on the International Space Station. Because how many people actually here knew that there was an amateur radio station on the International Space Station? Good amount of people. All right, excellent. And this actually got coverage earlier this year. Was a guy who decided to fly a near space balloon out of Britain. He's what they didn't actually cover, and I was kind of annoyed at this, is that he was an amateur radio operator, and that's how he got tracked his payload and how he got the images off, I believe. G0SEW, and I'm probably getting that wrong because I don't have my notes in front of me. So simply put, amateur radio is radio hacking, and I think we all like hacking here. So if you like radio, it's like peanut butter and chocolate; they go together. So let's start off with the first little bit of history. Amateur radio first started with the first experimenters. They were amateurs, and they wanted to start experimenting with this radio thing. So Marconi, Tesla, like the room behind us, and two names that you really might not know, Arnold Fessenden and Edwin Armstrong. They were early experimenters, and they did a lot of early groundwork and really brought radio to what we know it as today. Amateur radio in the U.S. was officially established in 1912 with the Radio Act. What a good idea for a name for a bill. Beats hell out of those stupid acronyms. So it was actually heavily influenced by industry, like Marconi, because they had their little sandbox and they didn't want anyone else in there, and they wanted to really shove any type of competition out. So the private stations were limited to 1,500 kilohertz and above, and just put it in today's terms, that's just above the AM broadcast band. Because right at that point, those frequencies were considered useless. No one will use those. No one can do anything with them. They'll die out in a couple of years. Oops. So one of the things you can do with amateur radio, and I think that's how everyone is familiar with, is that you can talk to everyone around the world. And you see, picture the big bearded guy with the suspenders talking in front of his huge radio with his huge antenna and, smoking a cigar or something. This is within the high frequency band. So now it's actually interesting because that's how the term got started, was high frequency. They limited us to the high frequencies. Then they started realizing there was a lot more frequencies above them. Oops. Usually a big radio, like the one right here, and there's a hand right next to it. They're big antennas too, because with the high frequencies, you need to have it. The radio wavelengths, which is the amount of a single cycle of a radio wave, is usually measured in multiple meters, like 30, 80, or 160. Lots of money to get started. It's usually a radio would cost somewhere between $500 to $15,000. A small radio down here, which actually we have on display and in use at the amateur radio station right on the 18th floor, that's pretty much the cheapest HF rig you can buy, and you can tell how small it is. You can also talk to people around your area. This is a VHF and UHF, which is very high frequency and ultra high frequency. So they started tacking on extra adjectives to describe high frequencies because they kept on realizing there was a lot of them. This goes up to 30 megahertz all the way up to 3 gigahertz. Most of the amateur activity is under 1 gigahertz. Smaller radios, and I meant to take this out. This is actually the radio in the upper portion here. It's a nice little handheld rig. It cost me under $200 to buy. And they're cheaper too. This was a relatively best bang for your buck rig, but there's radios out there that'll cost you more or less $100. They don't have as many bells and whistles as this one, but they'll get you on the air and they'll transmit a signal. The one down here, this is what would be referred to as a mobile rig, you can install it in your car. That'll cost you about, closer to the $500 range. Sometimes you get them cheaper, depending on what type of features. You can see them as cheap as $150, $200. So what's the difference between high frequency and very high frequency and ultra high frequencies? VHF, UHF is primarily line of sight. 5 watts, which is more or less what this radio will put out, will give you a few miles in average terrain. If you move up to a higher level, like say the 18th floor of the Hotel Pennsylvania, they'll give you even more range. Now, there's a special way of doing this where I don't always want to get myself on top of to a tall building to talk to people. So what people have done is they put something called a repeater on top of a tall point, at which point it listens to your signal and retransmits it. So I can use this radio to talk to as far away from Mike in southeastern Massachusetts. I can start talking to people in Rhode Island and such. High frequencies, it interacts with the ionosphere part of the atmosphere. Signals skipped off the ionosphere and are reflected back to Earth. It can go up to a range to hundreds to thousands of miles. Right now, not even an hour ago, we had 2 contacts off the N2H station. One was in Hungary and the other one was in Croatia. This was all through HF, and this was a very weak signal, even in amateur radio terms. It was only putting out 5 watts. Normally with HF, you're talking about 100 or so. There are subcultures in there that try to run as less power as possible, and there's also a culture out there that'll say, let's run as much power as possible. We have strange hobbies. So line of sight and repeater. So say, for example, I'm here. You can tell because of my chiseled jaw and wonderful hair. I'm talking on my small portable radio there, and I'm at a relatively high point. However, there's a very high mountain ranger in the back of me. Normally, I could talk to the space station down here because I'm higher than him, and I can hear him and he can hear me, but this mobile station wouldn't have been able to hear me. So some enterprising ham got on top of this mountain, and there's usually a commercial site on there, and we usually work out an agreement where, hey, can we, store this for cheap money because we're hobbyists? And they usually say yes. Sometimes we have to beg, borrow, and steal. They set up a repeater. We usually don't steal, it's just a terminology. So we set up a repeater, and what the repeater does, it actually could listen to me and the base station, and would retransmit my signal so that the mobile can hear me, even though I can't directly talk to them line of sight. And how this is accomplished is that the repeater listens on one frequency and transmits on the other. So what everyone does is transmits on the frequency it's listening to, and it can hear all of us, and it just retransmits on the frequency that everyone else is listening to, which is called their output frequency. So HF. It interacts with the ionosphere, as I said, and depending the way the radio waves bounce off of it and what type of angle that it's sent out at, and it's called the takeoff angle. That's how it depends on how your distance is. Like, for example, if you're really close to the ground and you're just looking to talk locally, you just want to have a nice little antenna, maybe 5-10 feet off the ground, and that will just talk out probably within a 50-mile or 100-mile radius. That'll talk to you in the next couple of states for you. unless you're in California, but that's another story. But as you get, relatively higher up, the angles of the radio waves start to decrease, and while you get that, initial 50 miles or so, you start talking about, 50 miles, 100 miles, 1,000 miles, and the lower the frequency, the lower the takeoff angle of your radio signal, it skips back on the atmosphere, and I'm sure the math majors here will know that the lower the angle of something that impacts would reflect lower off. However, with VHF and UHF, there are ways of extending your signal. One of the ways that people have done this is, you talk about a repeater, that's on top of a mountain. How much higher can we get onto that? There's people that like to fly airplanes with radios on them and like to talk to people 1,000 miles away. So when NASA originally started going up, there were a lot of amateurs, because that was more or less a technical hobby in NASA, and said, hey, let's go start putting some amateur radio up in space. Currently, there are about somewhere in the range of 10 to 20 orbiting satellites that carry amateur radio payloads. It's a lot of fun to operate them. There's 3 out there that are currently, as you can tell, this is a picture of me. I'm using a very large antenna, but I'm also using this radio. It's only 5 watts to bounce my signal off a satellite. And I don't know who I was talking to at this point. My friend took the photo, but I can talk in eastern Massachusetts all the way out to my longest contact was Arizona by bouncing my signal off this little satellite. It's called AO51 down here in the bottom right. That would reflect my signal, and it's basically a repeater in space. It orbits fast enough that people only get usually about 15 minutes of use for them by the time it appears over your horizon and then disappears over the other horizon. But it is a lot of fun to do operation. All of these, most of the satellites are low Earth orbiting satellites. The typical range, like I said, is about 1,500 miles max. There is one that just got launched earlier this year by China that can do transatlantic contacts on it. They're still kind of warming it up and fiddling with it, but I was sitting on top of a parking garage after I got out of work, had it. I knew that the pass was coming up and I could listen to it. I turned it on, and all of a sudden I heard a station from Spain calling, and I'm kicking myself because I didn't have the right frequencies programmed in to transmit to them. Yeah. Well, we can do questions. What's up?
Do you have to do anything special to track the position of the satellite?
Yes, there are programs out there. I'm not sure how many of you actually got here at 10 a.m. on Thursday like I did, because I'm gotta love a 15-month-old that keeps you awake. There's a bunch of free programs out there that will track these satellites for you and say, hey, this satellite is going to appear at such and such a time. It's going to be as highest point that you can see at about 5 minutes later, and then it's going to disappear 10 minutes later. One of the programs that Cheshire used at his talk, Cheshire Catalyst, was Orbitron, which is the one that I love. I actually don't have it installed in this, but I can try and show it to you if you stop by the amateur radio station later. There are geostationary satellites, not for amateur radio use. Because most of the time, the reason why there's mostly low Earth orbiting satellites is that we usually try to convince someone sending a rocket up, maybe to a geostationary orbit where their primary payload is getting put up, and they say, hey, load us into one of your second stages that gets lost in the atmosphere, and then we'll separate and take care of it ourselves. So we get kicked out on the ride up. It's cheaper that way. Currently, there is a satellite that they're trying to put into a what's called an HEO, a high elliptical orbit, and that can go almost up to geostationary, but then it rockets back around the Earth. But that can cover a much wider space. They estimated that it's going to cost them approximately $1 million to put it into space, and they don't have that kind of money. So we're kind of all scratching our heads saying, how do we get them that money? So data connections. Data connections, everyone's thinking, oh, data connections, my cell phone can do this. Yeah, it's been around for longer than you think. Late 1940s, radio teletype was around. A lot of these amateur radio operators coming from out of the World War II service found these surplus radio teletype machines, hook it up to their amateur radio transmitter, and started banging away on it. At a stunning 66 baud. VHF and UHF were fairly limited for speed. We're talking about 1,200 and 9,600 baud respectively. Unfortunately, with the amount of bandwidth that we have, it's not possible to get higher speeds than that. And I've tried to download something via TCP/IP connection once over this. It's painful. However, there is an alternative. First, we're going to take a little legal detour. Part 97 and Part 15. Part 15 is consumer devices. Every time you flip over to look at your remote next time you get home, and you'll see something on the stick that says, this has been certified by the FCC to be in conformance with Part 15 standards, and blah, 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 a bunch of legalese. Part 97 and Part 15 are both sections within the FCC rules. Part 97 governs amateur radio stations like myself. In more or less, in the FCC's eyes, we are an experimental service. We like to go around and do stuff. Part 15 governs consumer devices. Have to be tested by the FCC, and once they get that certification that they meet Part 15 rules, they can no longer be modified. Like I said, check out your TV remote last time, flip it over, you'll see the patents, and you'll see the FCC notice on it. There's a project called High-Speed Multimedia, and it's amateur radio bands that overlap the 802.11b and G and 802.11a band segments. Part 15 devices can be modified to fall under the Part 97 rule set, and that means that antennas can be modified, frequencies can be shifted, and wattage can be increased. How much wattage do you ask? Well, let's see. A Part 15 device usually puts out a max of 250 milliwatts. Part 97, on the other hand, currently, and I will talk about why I said currently in a moment, can go up to 100 watts for spread spectrum, which is what 802.11 falls under. And while you're kind of stupid if you really want to run this type of wattage, or you just don't want to have children again, you're legally entitled to do so. However, this may be the future. A few months ago, the FCC released something that they call a Notice of Proposed Rulemaking that says, okay, we will cut out some regulations on the spread spectrum side. However, we're going to reduce your maximum wattage down to 10 watts. All right, as anyone entitled as a citizen, but I did it as an amateur radio operator, I kind of replied to that notice of proposed rulemaking and said, okay, that's really nice, but how about we just cut it down to like 25 or something? I guess they're taking under consideration. I haven't seen a final ruling yet. I think it should be coming out within a month or so. I'll probably get ignored, which is understandable. They're a government agency. So one of the big things that are causing high-speed multimedia to take off in certain circles is OLSR, and I don't have my notes in front of me, so it's a mesh networking protocol that allows nodes to know where each other are. So say, for example, I'm at node A and I want to take to node B. There's a path there, that red line. It knows that is the shortest path possible to get to A to B. However, let's say what happens if all of a sudden this unit drops off the network. All right, well, it needs to route around it. So now that it knows that if it wants to go, my network, I want to talk to B, I no longer can talk to this node. I need to talk to this node that'll route me over to B. And along with also C to D, so say, for example, this one falls off, instead of taking the primary path, it knows to take a secondary path. And this is allowing a lot of amateur radio stations to talk to each other via data networks without having to make, giant fixed reliable stations. It's a mesh network. Everyone knows about each other else. Usually it's all your friends. If you see someone drop off, you can still route around it, but you call them up and say, hey, Jim, did your Wi-Fi connection drop off? Oh, geez, let me check. Oh, yeah, the cat knocked the power cable out. So everyone's saying, I know, come on, this is exciting, but I can do this under Part 15. Technically, you can't. It's illegal. If the FCC catches you doing it, you're going to possibly go to prison or face fines. Yes, it could happen. In most cases, they kind of just, no one ever complains, so no one ever gets caught. However, if you start interfering with your neighbor's Wi-Fi network and they know someone at the FCC and they trace it to you, you're going to get a little notice in the mail. That's a notice of apparent liability when attached with a nice little hefty fine to it. Thankfully, beyond this, anything goes. You can transmit what you want as long as you keep within that Part 15. It's a consumer device. You can use it for whatever you want as long as you don't modify it. Unlike, say, Part 97. With Part 97 amateur radio, this was part of what they were talking about with the original Radio Act. Nothing can be with a pecuniary interest, which means you can't make money via amateur radio. I can't start advertising my business or using a pizza delivery service, can't start using amateur radio to dispatch a truck, or nothing that makes money or makes my employer money. I also can't play music via amateur radio. because we don't want to cut in on Clear Channel's profits. Now, does this mean that, okay, so I have an MP3 file sitting on my server, my other friend hooked up to the wireless mesh network, my friend downloads it off my server. Did he just transmit music? There hasn't been a ruling yet. No one really wants to test that waters and possibly deal with that fine. Also, yeah, auto patch. He said auto patch as well, which is another type of pecuniary interest. Auto patch was big in the early mid '90s, where someone would hook up an amateur radio repeater and you could dial a phone with it. And everyone thought this was really cool at the time, but no one ever used it anymore because we all have cell phones. But it goes back to the same thing. I can't like call up my boss and say, "Hey, where do you want me to send me next for the my for computer consulting?" And he can't tell me where to go over amateur radio. That's another thing. With Part 97 on wireless, you also can't use encryption. Everything needs to be open and in the clear. No encryption. Everything has to be in the clear. So this actually is really interesting because people are saying, well, anyone can get on my network now. Well, no. And I kind of look at this as a great theme from the hacker side because I'm start saying, hey, IPsec. We all know IPsec. It's a standard protocol. We can use it without encryption, but only authentication. And everyone's kind of saying, well, geez, that would really work. How do we set that up? All right, well, let's work that out with you. There's also crazy third-party restrictions, and this is interacting with an unlicensed station, like, say, if you're on a wireless network and you interact with an internet via a licensed station, like myself, there's some restrictions, as in you can't start downloading naughty pictures or something, because that would be off-color, and that would also be against amateur radio regulations. Stuff you can do with HSM. I know, I'm sorry, I'm talking about all the stuff you can't do. It's your own private network. Do you realize that we actually, as amateur radio operators, have a giant Class A assigned to us that we can use for our own private use? And I'm talking about RFC 1918. No, this is 44.0.0.0/8. It's a Class A network. It's publicly routable internet space. If you can find somebody with a BGP connection, they can start advertising your subnet for you if you'd like. And it'll interact with the internet, and people will route it for you. As far as I know, no one has done this. I'd love to see someone try. It would be great. The moment I'm going to see on my web logs that I get a hit from a 44 address, I'm going to be jumping for joy. So it's a data connection across through your town or for telemetry. My friend Larry from paul.com, KB1TNF, he said, hey, what if I set up a UAV for war flying and use it to report back via HSMM? And I was like, that's a great idea. Like I said, if you have a friendly ISP, you can have publicly routable addresses. So as we start kind of moving into the internet age, we kind of started saying, hey, internet, looks like this might be catching on. So we started looking at ways of interacting with the internet via our radios, because we're geeks like that. What we came up with was two different ways of connecting radios together via the internet. And the Internet Radio Linking Project allows links between radios. There's also another project that is called EchoLink. That allows links between radios or a radio to a computer. Do I have a question in the back? Oh, sorry, okay. Don't worry, I've stretched before too. Feels just like high school. Both accomplish the same thing. They provide links between operators over IP-based connections. Now, also, it's an IP-based connection. It can be sent out over a high-speed multimedia network. Nothing's stopping that. So this is EchoLink. I don't have it installed on this laptop because I wasn't sure what the type of internet connection we would have here. And it needs if you do it between NAT, they kind of have some, you need to poke holes in your firewall, and because it doesn't like to do on RFC 1918 to internet addressing, at which point I start banging my head on the desk. Because these are a bunch of repeaters here, and what the operator has is Germany selected, and these are all repeaters that are EchoLink enabled, and I can connect to my computer via my computer and interact as if I was sitting there locally in Germany with a radio. There's also a ton of repeaters within the United States for it. We're actually attempting to try to find one within New York City that isn't used too often, so we can actually use the amateur radio station off of it, and people around the world can start trying to contact us if they would like to via the system. Another thing you can do with amateur radio is you can build and modify things. It's a defining characteristic of amateur radio. You name it, you can build it or hack it. Transmitters, amplifiers, transceivers, and antennas. Other services, like, say, Part 15 that needs to get approved, or what's the other one? GMRS, which is another type of communication system. They need to get, anytime they adjust their radios, they need to get FCC approval. We, on the other hand, can just sort of muck about and do whatever we want with them, as long as we stay within the approved operating parameters. This is a great example. This was actually during monsoon season, an amateur radio operator in India started seeing all of these villages start being cut off. So what he wanted to do is create a small, high-frequency radio that was cheap to build, easy to maintain, and rugged. So he came up with the BIT X20. And as we can see, it's a circuit board here. It's actually, in the grand scheme of things, that circuit board really isn't that complicated. I'm sure if no one's actually decided to crack open an end device, they're probably going, oh my God, that's so complex. But this is a fairly simple transceiver, and what it was used for, it was used to, like I said, used during monsoon season to lead villages and report back to other villages that, people are okay, we're fine, the road's been washed out, but, please airdrop us supplies or something. And it actually was used, I believe it was actually used in a giant flood they had there right after he started really rolling out this program. It performed admirably. And this is actually all open source. The schematic is all online. It's also, the PCB board is actually available for download and printing if you want to send it out to a PCB printing service. And you can set it up yourself, and I know a lot of amateurs that have just loved this because it's low power and they can take it on their camping trip with you, throw an antenna up into a tree, hook it up to a battery, and they're connected with the world. Another thing that's really interesting is starting to catch on is called software-defined radio. Now, software-defined radio allows for the replacement of various radio components that have typically been implemented in hardware down into a software program. Directly, and this is kind of a high level talking about if you don't, really nitty-gritty if you don't understand radios, but the direct result is a radio that's a lot more flexible, a lot more capable, and a lot more hackable. Like, instead of having to resolder a bunch of things to add a new filter or something, it's now, okay, let me go apply that patch I just downloaded off the internet. And it's side benefit to this, and they really wasn't a primary benefit when they first designed it, is that it's very easy to integrate into a computer. Now, after we started putting these radios into computers, someone said, hey, let's put it up to the internet. So this guy out in the, I'm going to mispronounce it, the University of Twente in the Netherlands, started creating a project called WebSDR. And it was a project to allow SDR receivers to be controlled over the web. And it's a PT de Boer PA3FWM. Initially one station at the University of Twente, Netherlands, and now almost 13 stations across the world. And what the upside of this is that I can connect to my connection. I can connect to an internet connection, load up a web page, and I can listen to frequencies from Netherlands, Eastern United States, Western United States, and I've had a couple of times where I'm trying to diagnose a transmitter issue, and I want to see, hey, am I getting out? Let's go tune into a local radio station or a close-by radio station and see if they can hear me. So let's try a demo. I'm sure this is going to fail miserably, and I don't have an audio feed because they accidentally messed up that my other presentation was supposed to have that didn't need an audio feed or document camera. They gave me that there, but they did not give me either here. Oops. Yes?
I just want to emphasize, with this WebSPR, multiple people can be connected.
Multiple people can be connected, and anyone here, because it's receive only, you can load this up, you can listen to HF bands. And what I'm going to try to do, oh no, please work. There we go, it's starting to feed up, and let's go unmute myself. And this is a graphical representation of the various bands. And what we have here is just below the AM broadcast band, which is receive only. Then we have just above the AM broadcast band, which is an amateur band called 160 meters. Then we start talking about 80 meters. That, when I start saying meters, it's the length of the radio signal, like I said before. So let's go. Yep, can you guys hear it at all? So that was Sugar Mike 6 Radio. That's in Sweden. And I guess he was calling CQ. Let's go try to find another. They're all avoiding me. Radio 6. Okay, so he's giving out his call sign right now. Actually, let me go make sure it gets on the recording. He's giving out a call sign right now and calling something called a CQ, which basically means, I'm here, anyone want to talk to me, please. And we've kind of been doing this over the amateur radio station. Anyone can stop by and we can do a demo for you. Let's see if we can't find another one. This guy is talking in some foreign language I don't know. And if we want to, we can also turn into Morse code. People still use this for some reason. I don't know it. It's a very condensed. Morse code is actually easier to understand and a lot simpler to build transmitters for. So a lot of people like to do it as a hobby within a hobby. So let's go mute it because I really don't feel like having this for the rest of my presentation. So this is the one that was in the University 20, and actually it's P.T. DeBoer's personal device, and he has it hooked up to the Radio Club's internet connection. It's 7 bands. This is the most complex one that's currently out there because he's kind of really leading the bleeding edge on this one. And but there's also ones in the United States. There's one in Spain. I believe there's one that's specifically geared towards satellite operation in somewhere in southern Europe. I forget where. But if you go to websstr.org, there's a link to every of the site that's available. And there actually could be more that I don't know about because I hadn't checked for a while. Okay, it actually did work, so I don't need to show you. This is the receiver that we were just listening to. And as you can tell, it's an antenna connection over on the left and an Ethernet connection on the right, which actually reports into another computer which does most of the web serving. But and right here, but the two main chips are, it's an analog to digital converter, and that allows us to actually hear the radio stations, and something that will allow it to tune all this stuff. This was the old WebSDR receiver, and it's just a amazing piece of hack. So you can tell all the major chips are still there. However, I really love this little small device right here, and I have mad props to him. It's a 2.2 millimeter wires on a 0.5 millimeter wire grid. And now you can tell why he's just sort of actually designed one and sent it off to be made for the new one, because I wouldn't want to do this once, let alone twice. So, everyone's talking about being green nowadays. Amateur radio is green. We love to repurpose, reuse, and recycle. Commercial bands often abut amateur radio bands. When people are throwing out and upgrading their commercial radio system, hey, we can take that from you, no problem. We'll take it out. We don't have to worry about making it, safe and disposing all that lead, no problem. GE, Motorola, EF Johnson, there's a couple other brands, can often be reprogrammed through software. Unfortunately, the software is not open source and highly expensive. However, a lot of people who do commercial radio stuff are often amateurs, so they have the software anyway, and you just got to buy them a 6-pack. Some other radios need simple hardware modifications, cut a resistor here, solder a capacitor there, and you're all set. Boston, up in my area, there's a group called GE Moto, which is GE and Motorola. That's the two products they love. They built an entire repeater network off the surplus 900 megahertz gear, which is the 33 centimeter band. Around a few years ago, the Missile Defense Program decided to, in Cape Cod and also in California somewhere, decided to say, hey, we're going to be starting up our giant radar array again. Unfortunately, this also sort of collides with your amateur radio band because we're the primary user and you're a secondary user, so we're kicking you all off. So what we did is we started crying into our beer, and then we started saying, okay, where can we go next? And we started looking at 900 megahertz, and someone said, oh, hey, I have the spare repeater. Let's go set it up and see what we can do. And so a few years later, we have this giant network now, and anyone within any of the colors kind of don't show up too well. Anyone within the colored area can talk to anyone else within that colored area via a network of linked repeaters via IRLP. And this photo is actually a little old because let's say right about here is a repeater we just added a couple of weeks ago at my club that had been tied into the network, and we can probably cover almost all the way out to Providence. So eastern Massachusetts and eastern Rhode Island, you can pick up a small little HT radio for about $100 on eBay. We can have someone program it for you, and you're tied into this network of repeaters. Works for pagers too. This is OH2LAK. That is in Norway, I believe. There's some question as to whether or not this is legal in the United States if we do this. People have been fooling around with it. No one's complained yet. But the amateur radio regulations say that every contact needs to be a two-way contact. And so when you're talking about a receive-only pager, what does that mean? Okay, so if I say, my friend Bob, hey Bob, I just sent a message to you on your pager, and the message says, please contact me at this such and such megahertz, and he contacts me later on that frequency, does that count as a two-way contact? Who knows? Some people say yes, a lot of other people say no. More recycling. I love it when work has a bad UPS because they don't want to get rid of it because they have to do all kinds of stuff with environmental things. I'll take that for you. I'll recycle the one bad cell that usually happens. There's usually 2 or 3 other batteries in there that are running at 12 volts. I hook them up to my amateur radio equipment. I have a battery. I can go lug it with me wherever I want, albeit they're kind of heavy, but whatever. So there's another protocol that's really starting to take off lately. It's called Weak Signal Propagation Reporter, and it's also pronounced WSPR. Woo! It's a digital mode designed to be heard by computers underneath the noise. So we have a bunch of static sitting out there on the bands. Now, if I listen with a human ear, I can't hear a bloody thing. But if I hook up a radio with a transmitter and receiver for WSPR, it can pull something out of that mess that my ear can't discern. It only takes 6 hertz of bandwidth. Now, a typical FM broadcast band takes approximately 10,000 hertz. Broadcast band signal takes about 10,000 hertz. The smallest voice transmission in amateur radio is called single sideband, and that takes 2,500 hertz. Unfortunately, when we're talking about bandwidth, more bandwidth means more speed. When we're talking about 6 hertz, we're talking about data being transmitted at a 1.46 baud. Ooh, don't try to download anything with that. Primarily, it's used to report band conditions in the HF bands. If someone just sits there and lets their transmitter go off and sees what people can hear them, and it makes a nice little Google map, which we'll see in a second. But and it shows you where your signal is getting out to. Can also be used for slow conversations. So, It's not spread spectrum in the specific sense. Yes?
Has anyone looked into, it's only 6 hertz, so could you just put a whole bunch of them next to each other with a properly designed transmitter?
Very much so, and this is exactly what this is showing. Each of these green lines here, keep on losing my mouse cursor, is a separate WSPR signal, and the black lines represent one time period, which I believe is 5 minutes. So, say for example, this is actually a QSO between 2 stations, if I remember correctly, and that took approximately around about 20 minutes to say, hey, I'm here. Hey, I heard you. Oh, cool, that's cool. I heard you too. Great, that's wonderful. That took 20 minutes to do. So when you're talking about 1.46 baud, it has its limits to it. However, if you just leave it sitting there banging away, you make this nice little Google map, and this is a map from, I think it's a VK4MDX, and he's right here. And these are the various stations that have heard him overnight on via his WSPR beacon. And the larger, the thicker the bands are, the more times they've heard him. So this WA7KGX in Washington State, it looks like, has heard him a lot, along with this Japanese station, JASWL, which would mean that someone is receive only and they may not be licensed. But they can still hear people, they just can't reply back. And they've also made it over to Ireland, that is Norway, I believe, and a lot of stations over in Australia have heard them. One of the big things that people kind of push in amateur radio is that we can do for emergency communications. It was part of the original reason for amateur radio's creation. Our secret sauce, and I'm going to tell it to you right now, is that we're a highly distributed communication system. If, say, for example, a tornado takes out the police station, all their radios are going to be there and they can't talk to anyone. However, it's going to be highly unlikely that a tornado is going to hit the 20 or so amateur radio operators that have separate houses. As long as one of those stations have survived, your communication network is up. And it's not just in time of disaster either. We like to do drills because we like to make sure that we're all set. And we also like to do public events. And this is a amateur radio group doing a marathon and they set up they have their nice little Army surplus tent, and they operate radio, and they pass traffic between water stations saying, so-and-so needs a refill, there's a runner down at such and such a mile marker, we need an ambulance at such and such. And one of the biggest events in my area is the Boston Marathon, and there's an amateur radio operator assigned to every water station on the 26.2 mile route. So, here's all the stuff that we could have done with amateur radio. What can you do for amateur radio? Because we need you guys. Build more things. Homebrew, which is creating transmitter, is alive and well. However, 99.9% of all projects are in the high frequency bands. Let's show some VHF and UHF some homebrew love in here. Let's go build some transmitters. Let's go see what we can do with it because no one else is. There's still innovation left in HF. There's homebrew SDR project. SDR is kind of exciting. It's kind of cutting edge. There's also something called minimalist radio. Let's see how few components I can use, still get a signal out that can be heard by people, and people can understand me. We also need people to push high-speed multimedia. It's woefully underutilized. It suffers from being classified as not being ham radio by the old-timers. I've gotten into many arguments like that, and while I don't condone elder abuse, I've had to really hold myself back. Just a couple of weeks ago, there's an event every year called Field Day. It's the last weekend in June, and what we do is we do a simulated emergency where we assume that everything has been blown up. We set ourselves up in a field, operate for 24 hours, and see how many contacts we can make. And I got into quite a few arguments about 900 megahertz and whether or not that is amateur radio. Some people think it isn't. A couple of high-speed multimedia devices placed in high elevations provide really good regional coverage. You place one station up into a very high point, you get a bunch of surplus DirecTV dishes because they're all tuned for 2.4 gigahertz. You point them to the central point, poof, instant network. Ham radio has steadily lost a digital speed race to commercial alternatives. I mean, look at everyone here probably has a cell phone that can do data. Let's go try to push back with innovation and see what we can do with it. We also need to push open source. Some amateur radio software is open source. A large portion is not. We're running all Linux at the HF station with open source products, so we're pushing it here. However, closed systems are starting to push into our bands. ICOM, which is an amateur radio manufacturer, started pushing something called D-Star, which was a protocol designed by the Japanese Amateur Radio League. It's great. It's an open protocol. Really cool. It's a closed codec that costs about $200. Yeah, that's not good. All of the innovation I've seen with D-Star, with people messing around with it and trying to hack it up, have been without the codec, because it actually does provide a digital data stream. That's kind of cool. There are some works in trying to make in a plug-in open implementation. I haven't seen much work with it, but from everyone says, oh yeah, we're working on it. Some amateurs really don't see this as a problem. D-Star, hey, we plugged it all in, it works great. I can go talk to anyone in the world just by my microphone. It's all integrated. It's a nice little public network on the internet. They don't understand that there's a problem when we start implementing closed systems. Simple stuff. Everyone here probably likes Arduino. I'd love to see more ham radio Arduino projects. I've done a nice little simple Morse code beacon, and it's up on my website if someone wants to see it. I think I have a link later on. It blinks out something. It's kind of overkill. I'm pretty sure, an NE555 timer can do the same exact thing, but let's see what Arduino can do. Actually, a couple of months ago, probably more like a month ago, someone has released an Arduino shield that does data connections over VHF or UHF radio. All you got to do is plug it into a radio. So, getting your license. And I don't know who Ken Crawley is. He just had his image of his license programmed, put on Google image search. Thanks, Ken. Just one thing about this, if you are into privacy and you're very paranoid, anytime you get an amateur radio license, it's a matter of public record where you live, because you are an FCC identified station. If you, Yeah, you can also get a PO box, but there are some questions by some people saying, that's not a operating station. I know a lot of people have done it. I haven't seen anyone actually get caught for it. Yes?
Just a comment, when I did my whole registration, I used nothing but the PO box, getting my FRN and my license. No one said anything about it.
Okay, so perhaps I'm unfounded.
I mean, you could be right, but, you know,
No,
that was the first concern for me too, because, you know, and a lot of people crawl that data.
yes. The advertisers, do we have a question in the back?
I have a PO box on my amateur radio license, and somebody get my information about some domains I own. He pulled up the address of the domain, put that into Google, and then found my amateur radio license. So I changed the address of my amateur radio license, the street address of the post office, and then box whatever.
That's actually
I
it.
actually received an updated license from the FCC at that address.
So I guess there are ways around it. If you want to maintain a post office box present, go for it. So getting your license, there's 3 classes. There's something called Technician, General, and Extra. Technician is the first class you would get. It's a 35-question exam. It's fairly easy. If you have a background or know anything about electronics, determining wattage, and you know what wattage, amperage, and voltage are, you got a good, and how to actually calculate them from each other, you got probably about 75% of the exam down already. If you pass your technician, the next class up is general. That's another 35-question exam. It's a little more tougher this time. They talk about different questions that of, designing antennas, finding resonant frequencies, more difficult stuff than the technician exam. Finally, there's the extra exam. It's a 50-question exam. That is some heavy-duty studying, actually. You can probably do it in about a month if you really dedicate some time to it. They start, feeding you charts and, saying, "Hey, look at this chart and find show me what exactly is this on this Gantt chart." All right. It's all multiple choice, and there's no Morse code requirement. So you do. Oh, my screen went blank. Well, I saw that go out, but I just assumed it was a light. Yep. Okay, so extra is a 50-best question exam. It's slightly more advanced. There's no Morse code requirement. Questions consist of basic electronics. For the technician exam, questions consist of basic electronics, operating procedures, rules, and regulations. Study guides are available online in dead tree format. I personally recommend Gordon West's WB6NOA. I've used his courses exactly. It's a very good. It's a very good system. Its books, they're available in Radio Shack, and I've done that through all of my 3 tests through my 15-year career. Yes?
I'm actually going to be going to the exam tomorrow morning, but I looked at it. I know what the technician is capable of doing, but could you say, you're teaching general and extras?
Well, technician allows you 50 megahertz and above, so it's that's actually changed since the last time I said this. You get mostly 50 megahertz and above. It's a free-for-all. You can do whatever you want up there within the amateur radio guidelines. You also have a couple of very small segments on HF that you can operate. When you start getting into general, General has more HF segments, and Extra even has more HF segments. Your operating privileges above 50 megahertz still remain the same. Question in the back.
Is broadband over power lines still really noisy in
Broadband over power lines, and amateur radio has been actively fighting against BPL because you have these wonderful long antennas, which are known as power lines, and you're transmitting data over them, which modulates and now creates a wonderful wide spectrum radio hash on all of our HF bands and even some on the VHF side. So we don't like BPL, and we are happily dancing on every time some community says BPL sucks, and we're like, yes, it does.
Comment, the
Yeah.
question pools are public, and you do sample tests on eham.net as well.
Yep. Like I said, like the gentleman in the front said, each class has its own question pool. There are about 10 times the number of questions on the test, rotated in every 4 years. Technician class, just this 1st of July, rotated into a new 4-year question pool. Each test is multiple choice. If you feel lucky about multiple choice exams, go for your amateur radio exam. Tomorrow, 10 a.m. to 1 p.m., floor 6. Tests are given, and if you don't feel like doing it tomorrow, you want to study up a little bit, they're given all over the place by volunteer examiners, usually multiple places every month. My local club gives a test first Saturday of every month. Cost is $14. $15? Okay. Okay. It's multiple choice. You have to be a United States citizen. I'm not sure. I'm not that I'm trying to classify you by your accent, but you have for the FCC. You have to be a U.S. citizen. Sorry. I did not know this until yesterday. So, no, I thought I was a U.S. citizen. That's what I've been told. Yes.
On ARRL,
Mm-hmm.
just want to mention if anyone's looking for an exam location, they have a searchable database.
Yep.
So you can say how many miles from your house you want to travel.
Okay. Question.
Yeah, if you felt like taking the test tomorrow, what does one have to do?
It's all up on the wiki. You have to perform a. You have to. The wiki is wiki.hope.net. Yeah, it's on the Hope Wiki. It's one of the projects down in the bottom right corner of the main page. You see amateur radio projects. All the information you need about taking your test is there. Yes.
How many of those questions do you have to get right?
You have to get. Yeah. Well, it's a certain percentage for for technician exam. It's 27 questions correct. Yes. Volt. Basic circuit diagrams, operating procedures, which you probably don't know about. You can look them quickly up online. Also, there's a couple of study guides directly linked on the Hope Wiki. Just want to see what my time's doing here, pardon me. Also, the Hope Wiki, there's a couple of PDF ones that if you want to feel like cramming before tomorrow. I think you were next.
The question pool, along with all of the correct and incorrect answers that were here on the test, are all public.
Yes, the question pools are completely public and open source. Open source. Completely public. If you want to download them, and if rote memorization is your thing, or you have a photographic memory, that's exactly what you need. Yes, yes, question?
I think the future of D-Star is, since Icon seems to be one of the lead manufacturers and the codec doesn't have any student resolution.
If I was able to predict the future, I'd be much richer right now. I see D-Star being a niche market at this point. There's currently one D-Star repeater in the Boston area, and that only went up about a year ago. There are people, I see a lot of things down in the south where everyone's like, raw, D-Star. But in the northeast, there's really not a lot to it. Okay, just for contact information, my webpage is... Here's my webpage and all that fun stuff. You can't see. Oh, crap. I hit the down button. Yeah, inismir.net. INNISMIR.net. Possibly, I don't know. I'll try to do it. If you look at N1WBV, if you look me up online, come on, nerdy one with big voice. Yeah, it's pretty funny, isn't it? No. Any other questions? I guess I kind of wrapped it up. I wish I could have left it. Yes.
Yeah, the WebSPR radio, how much does it cost to build one of those? And can they transmit or they receive only?
Not the WebSPR radios are usually receive only. Software-defined radios, I've never actually seen a real homebrew project for them. There are a couple of commercial alternatives. And they can be quite expensive, unfortunately. But I'd love to see someone do an open source implementation of an SDR. Oh yeah, that's right. That is a software-defined radio. GNU Radio, GNUradio.org. Pardon me. Yeah. Pardon. Thank you very much. I don't know who you are. What's your name? James. Everyone, thank James. Because I completely drawed a blank on that. Do they give manufacturing guidelines and all that stuff? Because I haven't seen them. I haven't looked them up in quite some time. Oh, awesome! I have to check them out. Thank you. So yes, GNU Radio. That's an open source web software-defined radio. Yes, in the back.
If I'm going to take the tech exam tomorrow, how long does it take?
As long as you want, up to 3 hours. If you can take as long as you want. There's no time limit to it. I guess you would probably. I usually averaged about 30 minutes on each one. Yep. It's not hard, and that's the hardest. That's the biggest thing I want to drive home. Not hard to get your license. Not hard to pass the test. I was able to do it as a high schooler in about a month, studying with under a month. Yep. Do we have a question up there? Sorry, I can't hear you. You can do that all on a technician license. I know a lot of people who have gotten their technician, they have no care about HF, they want to care, but all they care about is 50 megahertz and up, and they are happy to stay there. Me, I started dabbling in HF and say, hey, this is pretty cool, I'll go upgrade, and then it just kept on going. Much to my wife's chagrin, because the radios get more expensive. All right, that's time? Excellent, thank you very much. If you want to try to do some amateur radio, there's a nice little station right over there. If you don't want to try and just want to look on and see how other people do it, stop on by. I'd happy to answer any of your questions, and everyone else would be happy to answer as well.
What time tomorrow is the
10 a.m. to 1 p.m. It's all up on